Okay, hello friends. So in this video, we're going to talk about the ambiguous case of the law of sines. So my goal for you is to develop an intuition on when there is an ambiguous case. I actually think this is like pretty clear, but it's better if I go into like the why so that you have some intuition on this, because then it's not going to feel like you're just kind of feeling around in the dark. So this video is a little bit longer, but you should get why the ambiguous case happens and then mathematically kind of how to deal with it, which I think is pretty straightforward. So in my previous video on the law of sines, we reviewed the congruence axioms, and then we discussed different cases of when you can solve a triangle. So I've talked about case 1, case 2. So I'm not going to read all of these. I talked about this in my other video. I talked about case 3 and case 4. So when you have SAS and SSS congruence, we use the law of cosines, so that will not be in this video. But coming back to case 1 and case 2, so when you have SAA or ASA congruency, that was what I talked about really in my last video with using the law of sines. This was nice and straightforward. And so it always felt like the law of sines was like pretty simple to use in my last video. It was like very straightforward. Now, we're going to talk about case 2 in this video, where if you have this SSA, this could make more than one triangle. So just trying to help you understand like why does that exist. So there is no SSA congruence axiom, and so that's kind of that kind of explains like why this can get ambiguous, maybe. So we can solve the triangle. We can still solve the triangle when we have SSA, but we just need to realize that there could be multiple cases, and when there are multiple cases, mathematically we say there is ambiguity. That's why we say it's ambiguous. So let's consider how a side-side angle triangle, what does that situation look like? So just to get your head in the right space, I suggest that you just pause for a second and you just draw a little sketch of what you think this looks like. This will help the next part of this explanation to make a little more sense. So maybe pause for a second. Okay, so SSA, I start with a side, another side, and then an angle. And so you can see how to label all of these, right? So if this is side A, then this has to be angle A because that's the opposite. And okay, so this is how this side-side angle works. And so the measure of this angle A and then the lengths of A and B, this can create an ambiguous case. Not always. So I'm going to try to break this down for you. So a key to understanding how these cases work is also knowing just the height of the triangle. If we make some assumptions about the height of the triangle, that I think this can kind of clear up like where these ambiguous cases come from. So like if you just think about this situation I was just showing you, so what if this were the height of the triangle? If I know something about the height of the triangle, so look what happens. If this were the height of the triangle and I have this angle here, like, do you see how I run into like something is not right here then, right? So either I have to connect here to here and that's going to cut off this angle, or I'm going to have to extend down this way, which is not the angle that I have. So this is kind of like trying to just demonstrate, what if my height were here? So now I have the proper angle size, but see how, like, if this is my height, then I can't have side A. Or, you know, if this were my height, so let's say I've got it kind of going off to the side here, then maybe I would make everything work. So the height can dictate what happens with the sides. We're going to just kind of include it with the explanation. And I just want to give you like a quick run through just so you kind of have a visual understanding of this. So let's talk about these different cases. So let's say that I've got sides A and B, and A is the smallest from the height and then the longest side B. So this kind of goes with our first sketch. So I've got my longest side B, I've got the shortest side here is going to be A, and the height falls somewhere in between, so we can assume then that the height is going to be here. So, all right, like why? So in a right triangle, so remember, like this makes sense for the height. This will allow to get where your height could realistically be. And then the hypotenuse, like notice how this makes a right triangle. So B will definitely be longer in this situation because the hypotenuse is always the longest side when you have this situation. So we have like this sub right triangle here, so we can just see like why we know that H must be in between A and B now, okay? So Now, by understanding how the height works, we can also understand how the angle here works. So I've got my side, and then if I know that this is the height, so this should be the angle A that I'm making here. So this is where I'd want my next side to come. And you can see the issue with this, right? With how this is strictly drawn. There's no way, if I'm going to draw my other side here, obviously then this side is falling short. So you can't connect the sides if this is what my angle, or if this is what my situation is. So we just can't connect the sides. So actually this triangle then does not exist. So this is something that can happen when you have side-side angles. So just so that you have kind of this visual understanding of this, okay? So what about if I have that my A, so one of my sides is equal to the height, and then the height is less than B? Well, if this were the situation, what ends up happening if the height is equal to A, this is my height, this actually creates a right triangle, and then you'll have your other side A here, and you know you have this relationship between the angle A and then the height and the hypotenuse. So I've just kind of written like how this all has to go. So in case you were wondering, like, well, why do I know that A has to be this side? Why can't A be some like giant angle like this? This can't happen because the height is equal to A, we know this creates a right triangle. So if you're thinking, why can't I have a larger angle A, that will violate what we know about right triangles. So this just situation, it just simply can't happen. There's this relationship here. So we're like protected against that is what I'm trying to say, I guess. So this is not an ambiguous case. It's just a right triangle. Right triangles, we've talked about a whole bunch. So this is clear. So this is a nice scenario, nothing to worry about here. Okay, so let's talk about another scenario that can happen. What if side A now is greater than side B? So what we can assume then is H is somewhere in between. Okay, so if this is the case, so I could have this situation here, and then my angle A, this is actually not going to create any ambiguity. So I know that this side's going to be long enough. These two sides will match. This is not ambiguous. Okay, so now let me show you the case that actually is ambiguous. This is a little odd, where the height ends up being the shortest part of this relationship. So H is less than A, H is less than B. Okay, so I create my sides A and B, and then I have my height here. So the height is the shortest of the three, the smallest. So I get this angle A. So looking at this situation, it's like, oh, I could just connect this and we're good, right? But actually there's an ambiguity here. So let's talk about where this other case comes from. What I'm going to do is I can actually take this side and I can, so think about like visually like pivoting this. So from this point, let me pivot it this way. So what would that triangle look like? I'm going to pivot this way. So I still have the same height. I still have the same length A. I'm still maintaining the angle A. And then it's like, oh, snap. So now I can connect these two sides. So I actually, keeping everything else the same, I haven't hurt, angle A, I haven't hurt side A, I haven't hurt side B. I have two possibilities. So this is actually the ambiguous case. Like visually, this is what's happening here. So we can also talk about this. I've been showing you acute angles. This can also work with obtuse triangles. But I think you get the idea, so I'm just going to move on from this. So just so that you kind of like intuitively understand on some level what's going on. All right, so the point is, when you have SSA, you need to know which kind of situation you have. Are you in a case that's ambiguous or not? And this feels very tricky, but there's some clues for which situation we have. This is actually pretty straightforward, so don't worry if you're like, oh, this feels really confusing. The point was for you just to kind of have that intuition, and now I'm going to show you like mathematically how this all comes together, and I think it's actually pretty straightforward. So let me just give you a few tips for applying the law of sines. Okay, so just sine function 101, it has to be less than or equal to 1, okay? If this does not hold, then you just get to say the triangle does not exist. So this is going to be very helpful. And then if you find that for any theta, you have that sine of theta equals 1, that means that theta equals 90, and so you have a right triangle. If you have a right triangle, then you know it's not ambiguous, okay? So when I was talking about this situation here where the triangle did not exist, we will see the issue mathematically with this in a moment. Maybe visually you're like, oh, this, like, I'm not sure how I could tell this, or I'm a little confused. Mathematically, actually, it's going to make a lot of sense. So this situation, just kind of keep it in the back of your mind. We'll tie it all together in a moment. And then this other situation, so where we found that the height was equal to a, this is clear. So when this happens, again, this is ideal. Okay, so the next tip I have for you is to remember that supplementary angles have the same sine value, i.e. sine of theta is equal to sine of 180 degrees minus theta. We're going to use this fact a bunch when we are working with ambiguity, so I'm just going to state that for now, and I'll show you how to use it in a second. And the third thing I want to tell you is the smallest angle is opposite the shortest side. Okay, that's very important. Or the largest angle is opposite the longest side. If this does not hold, the triangle does not exist. So just keep this fact in mind. This is just something to help you with your intuition. It's just a consequence. So keep it in mind as we're going through everything. All right, so I'm going to show you now how this works. So I've got solve triangle ABC if A equals 16.2 centimeters, C equals 14.1 centimeters, and C is 72 degrees and 30 minutes. Okay, so let's create this triangle. So I've got side A, 16.2, and then I've got side C, that's 14.1. And then angle C, where does that fall? Angle C, so I've got side A, side C. Angle C is going to be here, right opposite of side C. So this should be clear. And I know that this is 72 degrees and 30 minutes. All right, so now what I'm going to do is I'm going to try to figure out what is angle A. Angle A should be the angle right here, right? Okay, so what I'm going to do then is I'm going to use my law of sines. So I take A over sine of A equals C over sine of C, plug in all this good stuff, and now I can work towards solving sine of A. So when I do that, so here's the work. Here's like mathematically what happens to solve for sine of A. And so if I punch all of this good stuff into my calculator, I get 1.096. And so we have an answer. Do you remember what I was saying earlier? This triangle does not exist because, remember I said the sine value cannot be greater than 1. This is greater than 1. So the second you find that a sine value is greater than 1, actually that's just boom, triangle doesn't exist, you're done. So like I said, it's actually kind of obvious when this happens. So cool. All right, so that's one case. Let's talk about another case now. So let's solve triangle DEF if D equals 62 degrees and 8 minutes, D is equal to 34.5 inches, and E is equal to 38.1. So what I would recommend is that you just take a second to draw the triangle DEF, and you draw this situation on your own just to make sure you get it. So I'd pause and draw and then hit play. Okay, so I've got sides D and E, and then angle D is going to be over here. Boom. All right, so that is 62 degrees and 8 minutes. Okay, so now the next thing that I want you to do, just set up the law of sines here and solve for angle E. That's what I think you should do. I think you should pause the video. Math is not a spectator sport. Give this a try. Hit play when you're ready. Okay, so I'm going to set this up. So I've got E over sine of E equals D over sine of D. So I can just plug in my information that I have in the problem, and I can solve for E. So if I solve for E, here's all my work to solve for E, and I get 0.97629. It's a decimal. All right, so this is good, right? This is less than 1. Great. So let's think about this. So I've got sine of E equals 0.97629. So now I want to solve for E. So to solve for E, I'm going to go ahead and take inverse sine. Now, I'm going to solve for this, and I get that E is equal to 77.497 degrees, right? All right, cool. And just a friendly reminder, make sure that your calculator is in degrees. Okay, so I just want to clear this up because I think this might get a little confusing. You might be thinking now about, oh, inverse sine, so then I've got to think about what intervals are we on, and then I'm only supposed to be in this part of the unit circle. So when you plug this into your calculator is referencing this information about which quadrants you're supposed to be in. That's what your calculator's thinking of. However, we aren't talking about inverse functions strictly. Our context here is triangles. And so because of that, what we're going to do is we could take the other part of the unit circle into account, i.e. we can go ahead and take 180. That's where that second tip I was telling you, that's why I brought that up. So now what I'm going to do is I'm going to go ahead and find a second possible angle, okay? So I take 180 minus 77.497, get 102.503. All right, so now the question is, so what I'm saying is maybe we have two possible triangles. What we have here is a situation where E could be 77.497 or it could be 102.503. And so the question is, like, how can you be sure of this? So here is the next thing that you want to do. Let's explore this a little farther. I've got these two possible E's, angle E's. So what I'm going to do is I'm going to try to figure out, can an angle F exist if I have these two measures, either of these two measures? So how can I figure out if angle F exists? Well, I've got one angle and then I got a potential second angle. So what I'm going to do is I'm going to take 180 minus the three angles in both cases. So I'm going to take 180 minus 62 degrees and 8 minutes minus this other one. So I know I'm mixing my decimals and my minutes, but I'll convert it all back in a little bit. So I can go ahead and do this calculation here for both sides. So I did this for the calculation of 77.497, and then I did the calculation for this 102.503. And look what happens. I get two possibilities for that final angle F. And so this is that ambiguous case. This is the ambiguous case that we were looking for. So this doesn't always work out, by the way. This is very obvious whether you have an ambiguous case or not. When you have two possible angles, it'll be very clear. I'm going to show you some examples where this doesn't work out so that it's not so confusing. But in this case, we have two possible triangles. And so now what we're going to have to do is we're going to have to solve both of these possible triangles. So two possibilities. So one thing I'm going to do here is I'm going to convert these to minutes before I move on. So like I said, I was being a little sloppy here, so I've converted both of these to minutes. And then the other angle, I've converted everything to minutes and seconds, so I'm all squared away here. So now what I've got to do is I've got to solve these different triangles. So we're going to find the other sides in both of these situations. So now I've got situation one, where I assume E is at 77 degrees, 29 minutes, and 49 seconds, and the F is listed here. So here was my original situation I was starting with. And now I can label the rest of this triangle. Here's my angle F, here's my angle E, and now I can just go ahead and I can use the law of sines to figure out what is my remaining side F. And so I can just take F over the sine of F, so 40 degrees, 22 minutes, and 11 seconds, and then I can take side D over sine of D, as you see here, and then I can just go ahead and solve for F. So I can solve for F, as you see here. I've got all my calculations, and ultimately what I get is that F will come out to 27.915 degrees, or inches, sorry, inches. Okay, so that was the first triangle, and now I gotta pivot, and now I gotta do this again for the second triangle. So I'm gonna draw another sketch just so I don't get confused. I've got, here was my original sketch. I'm gonna label my other sides. And so once again, I'm now gonna use the law of sines to find my side F. Personally, I think you should pause the video here and you find the other side of F just to make sure that you're keeping up with this and this is making sense to you. Okay, so I'm going to set everything up. As you see here, I've got all my work. So ultimately, when I solve for F, I get 11.42 inches. And so now I've done it. I've found all the possible angles and sides of either situation, and I've found two different sides F. And that's what you have to do when you have an ambiguous case. All right, so let's talk about now determining the number of triangles you get with SSA. So this only happens when you have this SSA situation. So we're going to make sense of this. So when you have SSA, so like I said, when you find that the sine of theta is greater than 1, boom, no triangle exists. We just get to move on. Hooray. Now, if you find that you get theta is equal to 90 degrees or sine of theta is equal to 1, then you know you have a right triangle. You don't have to worry about this. There can only be one triangle. Okay, and now for the third tip, and this is going to be very helpful. I'm going to show you how to use this more. So let's say now that you get your sine of theta is less than 1, then you might have an ambiguous case. So what you're going to do is you're going to find the first angle. Let's call that angle B1. So you find that angle like we were doing before. And then you do that 180 minus that that angle that you found. So let's say I've got angle B1, and then I've got the other possibility of what the angle could be, B2. There's actually a very quick check as to whether or not you have a second triangle. If you take B2 plus your given angle, and that's less than 180 degrees, then you have two triangles. Okay, so just keep this in mind. Maybe this doesn't make sense. I'm going to show you how to make sense of this in a moment. And then I think we'll tie everything together, and then hopefully you feel pretty good about this. Okay, so here's what we're going to do. I now want to do an exercise. The entire point of this exercise is just to figure out how many triangles there are. That's it. And what and if we even need to worry about an ambiguous case, okay? So I'm going to give you some information about a triangle, ABC, and I'm going to show you how to determine whether or not you have to worry about the ambiguous cases and all that stuff. So I've got B is equal to 80 degrees, C is equal to 35 degrees, and then I have side B is equal to 27. Okay, so the thing I would recommend every single time you get your information, draw a triangle, make sure you have it all properly labeled with all the sides and everything so that you can easily fill it in, and then fill in the information. And now that you visually see this information laid out in front of you, you can see what is the situation. I have an angle, and a side. So this is AAS. And so with AAS, so because we know two angles, we can actually find the third angle by taking 180 minus those other two angles. So I actually can figure out a lot of information about this triangle right away. And okay, so I know that that side is 65. And because I can manipulate that, so this is important, I can now manipulate this into side, angle, angle. So by finding that third angle, what I have created is now I can say, oh, I've got this congruency. I talked about in the other video, like you can sometimes kind of like massage the problem to figure out that you have a different type of congruency. So that's kind of what I mean. So I've got now I see I've got side, angle, angle, or you could think of this as angle, side, angle, doesn't matter. Anyways, so that situation, side, angle, angle, that brings us to case 1. When we have case 1, we don't have any issues. So I just know that it's going to be, I know that this is going to just be one triangle. So I don't have to worry about, oh, is it ambiguous or not ambiguous? We don't have to worry about it. Okay, so let's try that again with B here. So I've got A is 60 degrees, B is 70 degrees, C is 5. Why don't you draw the triangle and you just look at it for a moment. Maybe hit play when you're ready. Okay, so here's my triangle. Got my sides. I'm going to fill it in. And so now I can see that I've got angle, side, angle, right? So that's angle, side, angle. And so that is still case 1, right? Angle, side, angle. I don't even have to figure out the other side because just with the information that I was given, I can see that I have angle, side, angle. So no issue here. We don't have to worry. Okay, so now let's take a look at some other examples. So now I've got A equals 15, B equals 24, and B equals 33 degrees. So I'm going to draw my triangle, label everything as you see here. All right, and so now looking at this information, I've got a side, and an angle. And so that is case 2. So you actually really need to know if you're in case 1 or case 2, because if you're in case 1, you don't even have to worry about the ambiguity thing. When you have case 2, there could be. So now we just want to be careful. So at least we know to be careful. So what I'm going to do now with the information that I've been given is I'm going to find angle A. Okay, so I go through and I've got 24 over sine of 33 and then 15 over sine of A. So let's go ahead and solve for sine of A. So I go through, I solve for sine of A. I get that sine of A equals 0.34. Okay, so now that I know that sine is equal to 0.34, I can go ahead and I can find side A, or I can find what the angle A is. And so I take inverse sine, it's 0.34, and A is going to be 19.9 degrees. Okay, so now I have to do that 180 thing. So I take 180 minus 19.9 degrees, and I get that this is equal to 160.1 degrees. And so the question is, are there two triangles? So I want to show you a couple different ways to get at this. Like just logically, does it make sense that there could be two triangles? Let's see. So let's say that I have this first angle 19.9. So if I have the first angle 19.9, what would the three potential sides be? The three potential sides, remember I was given 33 degrees. I found 19.9. So if I just do the math, 180 minus 33 minus 19.9, that means that the last angle would be 127.1 degrees. So the three sides, or I guess I should have written corners, would be 33, 19.9, and 127.1. This is a legit triangle, right? This is okay. Now, I want to just compare that to what if I had the other angle I found, the other case, 160.1. So what happens then? If I take 180 degrees minus 33 degrees minus 160.1 degrees, look at what happens with my math. This gives me negative 13.1 degrees. Does that make sense to be the other angle of a triangle? No. So I can see logically then, this 160.1 degrees, it is not making a second triangle. Only the first case exists. Okay, so that's logically what's happening. Now you might remember that I was telling you about that third tip. Now I'm going to show you a faster way to figure this out versus having to sit here and do all these calculations. There's a much faster way. So the faster way to figure this out is if I take this, so I took 180 minus 19.9, I got 160.1. This potential other triangle angle, if I take that plus the given angle, so 160.1 plus my given 33, look at what happens. This equals 193.1 degrees. That's greater than 180. You cannot have two angles of a triangle be greater than 180, right? They can't even equal 180 because you still need the other side. So if this happens to be greater than or equal to 180, boom, it's not possible. So I can tell then, just because I got 160.1 and I can do the math in my head, that this would not have worked. And so this is the shortcut to tell right away whether or not you actually have an ambiguous case. So you don't have to worry about it's all mathematically something you can just kind of hash out. All right, so let's do another one. A is 25 degrees, side B is 8, side A is 11. And I think you should try this. No, really, I think you should try this. So you take a moment and you try to figure this all out. I want you to sketch it. I want you to just repeat everything we're just kind of talking about and giving you the space to do this. Math is not a spectator sport. You're not going to get this unless you take a moment to really digest all of this. Hit play when you're ready. All right. So I've got side angle. When I draw my sketch, I have side angle. So possibly ambiguous, right? So now I got to go through a little bit of work to figure out, is it the ambiguous case or not? Okay, so I've got 11 over sine of 25 equals 8 over sine of b. So I go through and I try to figure this out. And I get that, so I've just written out all the work here. So I'm assuming that you tried this on your own. So if not, you can pause just to see all the work I did. But what I get is, so my angle B is 17.9 degrees. I should have written degrees there, sorry. Okay, so now I want to figure out, do I have two issues, or do I have two triangles? So I take 180 minus 17.9, I get 162.1. So remember that little trick I told you about, right? I can take 162.1 plus my given angle, that exceeds 180 degrees. So because that exceeds 180 degrees, there's just one triangle. So I don't have to worry. So then I can just finish solving for the other side is what I'm saying. So then you just finish it business as usual, figure out what C is, all that good stuff. Okay, so let's try this again. What about E here? So again, I think that you should try this. Here's the situation. You can hit pause, you try to figure this out, and then hit play when you're ready. Okay, so I've got my given information. So I'm going to go ahead and figure out what angle B is, I guess. So I go through and there's all my work. So here's my angle B, 75.24. Okay, so I've got my work here. I take 180 minus 75.24. I get this as my other potential angle. So now, what's the trick? I take that 104.76 and I add it to the given. So when I add these two things up, I get 166.16. That is less than 180 degrees. So in this case, I have two possible triangles. So now I've got to do this twice. I have to first assume that angle B is 75.24, and I have to figure out the rest of the triangle. And then I do it a second time, and I assume angle B is 104.76, and I redo all the work with the new angle. Okay, making sense? All right, one last one. Once again, I think you should try this. Hit play when you're ready. Okay, so I label my triangle, and now I'm going to go ahead and find my other angle. So the angle that would make sense here would be angle A. So in this case, when I go through, I get sine of A equals 1.2666. I get this whole decimal. All right, what do we do? So this number, 1.2666, is greater than 1. The triangle, therefore, does not exist. We are done. We don't have to do any more work. We are good to go. So once you get that sine of A, or your sine is greater than 1, don't go any farther. You're good to go. Okay. So the last thing I just want to talk about here is, so without using the law of sines, explain why no triangle ABC exists satisfying these three conditions. B equals 95 degrees, B equals 40 centimeters, and C equals 46 centimeters. So I would recommend that you just think about this for a moment. I kind of gave you a big hint about this earlier. Maybe think about it and then hit play when you're ready. So remember when I was talking about tips for applying the law of sines? So just in general, the smallest angle is opposite the shortest side, and the largest angle is opposite the longest side. So if this does not hold, then you cannot have a triangle. The triangle does not exist. So while I could technically apply the law of sines to figure this out, just notice if I have the angle B equals 95 degrees, that's going to be the largest angle in the triangle. And then the remaining 85 degrees in that triangle are going to be split between the other two. So this is going to be the largest angle. So notice B is 40 and C is 46. So 46 is larger than 40, right? So at a minimum, 95 would have to be across from 46, but it's not. We can see it's across from 40. So because of that, these two pieces of information, these do not line up. So the triangle cannot exist. And so that's the type of reasoning that you can use for those kinds of problems. And okay, so we are done. If you found this helpful, please consider liking the video or leaving a comment, sharing with your friends, or subscribing to the channel. That is all I have in this video, and I have another video coming up for you guys on the law of cosines, so we can kind of round out the rest of these cases. So I'll see you in another video.